Welcome to the Secondary System Configuration module, which explains user authentication methods and configuration. The module also explains how to configure and analyze system logging and tracing. In addition, it demonstrates how to monitor and configure Network Time Protocol, or NTP, and SNMP, and archive configurations. The Junos OS authentication methods help to assign access permission to Junos devices and specify which users can or cannot access the device under certain conditions. Secondary system configurations help you to monitor Junos network devices and identify network outages and protocol failures with the help of system log and SNMP messages. At the end of this module, you will be able to configure user authentication, configure and analyze system logging and tracing, configure and monitor NTP configuration, archive configurations on remote devices, configure and monitor SNMP. The Junos OS uses three types of user authentication methods: local password authentication, radius, and TACX+. Click each label to learn more. You can configure devices running the Junos OS to be both a Radius and TACAX Plus client, and you can prioritize the order in which the software tries one or more of the three different authentication methods. For each login attempt, the Junos OS tries the authentication methods in order until the password is accepted. The next method in the authentication order is consulted if the previous authentication method failed to reply or if the method rejected the login attempt. If no reply, accept or reject, is received from any of the listed authentication methods, the Junos OS consults local authentication as a last resort. Let's look at some examples to understand how authentication order works for different configurations. Click each button to learn more. Each command or configuration statement is subject to authorization. The Junos OS applies authorization to all non-root users, and this feature cannot be disabled. Authorization applies to both the JWeb interface and the CLI. A configured hierarchy of authorization components, as shown in the figure, defines whether a command is authorized. The different components of authorization are users, class, permissions, and allow and deny overrides. Click each label to learn more about these components. Consider the authorization configuration example displayed on the screen. This example shows how the various authorization components are configured. User Nancy is a member of the NOC admin class. The NOC admin class has the clear network reset and view permissions. The NOC admin class can enter configuration mode using the configure private command and is allowed to alter configuration parameters at the edit interfaces and edit firewall hierarchy levels. The NOC admin class is denied the ability to manipulate files using the operational mode's file command and is specifically excluded from navigating to or viewing configuration details at the edit groups hierarchy level. System logging or syslog operations use a Unix syslog style mechanism to record system-wide high-level operations such as interfaces going up or down or users logging into or out of the device. The Junos OS places the results of the logging operations in files that are stored in the /var/log directory. The primary syslog file, which is included in all factory default configurations, is the /var/log/messages file. The Junos OS supports a number of facilities and severity levels. The facility is listed first and defines the class of log messages. The severity level is listed second and determines the level of detail to be logged. Syslog information can be logged to individual files such as the /var/log/messages file, or it can be sent to a remote server. Remote logging and log file archiving is recommended to aid in troubleshooting efforts. Various syslog configuration examples, including a number of the default settings, are displayed on the screen. Syslog operations can be enabled or modified at the Edit System Syslog hierarchy level and the Edit Routing Options Syslog hierarchy level. Note: factory default settings are indicated with an asterisk. Click the Additional Information button to view general syslog configuration options. When using the standard syslog format, each log entry written to the messages file consists of several fields. The timestamp field indicates when the message was logged. The name field displays the configured system name. The process name, or PID field, displays the name of the process that generated the log entry, or the process ID when a name is not available, that generated the log entry. The message code field provides a code that identifies the general nature and purpose of the message, and the message text field provides additional information related to the message code. Note: when you add the explicit priority statement, the Junos OS alters the syslog message format to include a numeric priority value. In this situation, the value 0 indicates the most significant and urgent messages or emergency, and 7 indicates debug level messages. Refer to the System Log Messages Reference documentation for a full description of the various message codes and their meanings, or use the CLI's help function to obtain this information. The displayed example shows the operator obtaining help on the meaning of the UI_dbase_logout_event message code. Based on the output, you can see that the message code shows a command that a user entered at the CLI prompt. Tracing is the Junos term for what other vendors sometimes call debug. In most cases, when you enable tracing through configuration, you create a trace file that is used to store decoded protocol information received or sent by the routing engine, or RE. The Junos OS sends the tracing results to a specified file stored in the /var/log directory, or to a remote syslog server. To enable remote logging, specify a syslog server at the Edit System Tracing hierarchy level. You might see a warning when using the Remote Syslog Server option. If the syslog server is configured properly and you have verified that the logs are being received on the server, you can safely ignore the warning. Note that because of the design of the Junos OS, you can enable detailed tracing in a production network without significantly impacting performance. Even so, you should always remember to turn off tracing once you have completed your testing to avoid unnecessary resource consumption. You can use the Trace Options statement at the Edit Protocols Protocol Name hierarchy to trace the operations of a specific protocol. Consider the example displayed on the screen. In this example, the OSPF protocol stanza reflects a typical tracing configuration that provides details about OSPF events and errors. The trace results will be written to the file /var/log/ospf-trace. Configuration options allow you to further configure the trace files. Click the Configuration Options button to view configuration options for tracing files. Flags identify what aspects of the protocol are traced and at what level of detail. You can trace multiple flags to a single file. You can also use the detail parameter with a given protocol flag for the added information often needed in troubleshooting scenarios. Note, when using the trace options statement, you should be selective in what you trace because selecting the all keyword is likely to provide too much detail. By default, timestamp information is placed at the beginning of each line of tracing output. If you do not wish to have timestamps on each line, you can use the hidden No Stamp Trace File option in the Trace Options command. Trace options are also available at other configuration hierarchies. The Trace Options statement at the Edit Interfaces Interface Name hierarchy level enables you to trace the operations of individual interfaces. You can also trace the operations of the interface process, which is the Device Control Process, or DCD. Note, when tracing a specific interface, the specification of a trace file is not supported. The Junos kernel does the logging in this case, so the tracing information is placed in the system's messages file. In contrast, global interface tracing supports an archive file. By default, /var/log/dcd is used for global interface tracing. By default, the Junos OS stores log and trace files in /var/log. To view the stored log files, use the show log command. To display file contents, use show log file name. Note, when displaying the results of the show log command, the CLI automatically pauses when more than one screen of information exists. At this More prompt, you can enter a / to conduct a forward search. You can also enter H at a More prompt to view the context help screen of available commands shown in the example. The ability to cascade multiple instances of the CLI's pipe functionality is a real benefit when you must search a long file for specific information. You can also use multiple instances of the pipe functionality to evoke a logical AND search, and use quotes to evoke a logical OR search. Use the Monitor Start CLI command to view real-time log information. You can monitor several log files at one time. The messages from each log are identified by file name, where file name is the name of the file from which entries are being displayed. The Junos OS displays this line initially and when the CLI switches between log files. Note, for a user to monitor a log file using the Monitor Start command, the user must have the required access permissions to view the referenced log file. Also, because the Monitor Start command depends on the logged information being written to the log file first, the system must have the needed storage space for the log file, and the log file must exist. To determine which log files are being monitored, you can issue the Monitor List command. You can use the pipe functionality with the Monitor Start command to filter the file being monitored. Note that you can use the CLI's Match functionality to monitor a file in real time while displaying only entries that match your search criteria. You can use Escape Q to halt and resume real-time output to screen, and use the Monitor Stop command to cease all monitoring. Note, if no output sends to the screen after issuing the Monitor Start command, you can use Escape Q to check if a previously initiated monitoring session was frozen rather than stopped. If you do not delete or disable all trace flags, tracing continues in the background and the output continues to be written to the specified file. The file remains on the storage device of the system until you either manually delete or overwrite it according to the Trace Options file parameters. To disable all tracing at a particular hierarchy, issue a Delete Trace Options command at that hierarchy and commit the change. To truncate files used for logging, use the Clear Log File Name command. To delete a file, use the File Delete command. Note, you can also use wildcards with the file commands delete, compare, copy, list, and rename operations. The Network Time Protocol, or NTP, enables you to synchronize network devices to a common accurate time source. By synchronizing all network devices, timestamps on log messages are both accurate and meaningful. Correlated timestamps on log files help in troubleshooting. The Junos OS supports client, server, and symmetric modes of NTP operation and can also support broadcast and authentication. It is recommended that authentication be used to ensure that an attacker cannot compromise synchronization on a system. Click the Additional Information button to understand how NTP works. A typical NTP-related configuration stanza is displayed. Two machines can synchronize only when their current clocks are relatively close. By default, if the time difference between the local device's clock and the NTP server's clock is more than 128 milliseconds, the clocks are slowly stepped into synchronization. However, if the difference is more than 1,000 seconds, the clocks are not synchronized. A boot server is used to set a system clock at boot time to ensure that it is close enough to later synchronize to the configured time server. Issue the operational mode setDateNTP address command as a substitute for a boot server. Use the showNTP associations command to display synchronization status. To view further synchronization details, use the showNTP status command. In the output of the showNTP associations command, the address column shows the hostname or IP address of remote NTP pairs. The symbol next to the hostname or IP address gives the status of pairs in the clock selection process. Click the Additional Information button to view a list of possible symbols. Certain failures might render the storage device, which holds the configuration files, unusable. In the event of such a disaster, it might be helpful to have the most recent configuration file stored on a separate device, such as an FTP or SCP server. To automatically back up the configuration file of a system to a remote device, configure the necessary configuration archival parameters at the Edit System Archival hierarchy level. When you configure the system to transfer its configuration files, you specify an archive site in the form of a URL to which the files are transferred. If you specify more than one archive site, the system attempts to transfer the configuration file to the first archive site in the list, moving to the next site only if the transfer fails. Backups occur at regular intervals with the use of the transfer interval statement. The frequency at which the file transfer occurs can be from 15 to 2,880 minutes, and you can define this frequency. Alternatively, the configuration file can be transferred every time a new configuration becomes active with the use of the transfer on commit statement. Upon entering a commit command or reaching the specified time interval, the system copies the configuration file into the /var/transfer/config directory, and an FTP or SCP session is opened with the remote storage device. Once the configuration file is transferred to the remote storage device, a system log message is generated, confirming success or failure of the transfer. The destination file name format is displayed for you. Note, the destination file name format cannot be altered by configuration. Devices running the Junos OS act as SNMP agents. An SNMP agent exchanges network management information with SNMP manager software running on a network management system, or NMS, or host. The agent responds to requests for information and actions from the manager. By polling managed network devices, the NMS collects information about network resources. An SNMP agent can also notify the NMS of events and resource constraints using SNMP traps. An SNMP agent communicates with the SNMP manager using these message types: GET, GET bulk, or GET next requests, SET requests, notifications. Click each label to learn more. A Management Information Base, or MIB, is a collection of objects maintained by the SNMP agent in a hierarchical tree structure. It is used to define managed objects in a network device. The SNMP manager views or changes objects within the MIB structure. MIBs can be defined at the enterprise level to provide enterprise-specific information about the managed network device. MIBs can also be standardized to provide common information across multiple vendor network devices. NMS devices poll object identifiers or OIDs to retrieve management information. An OID is considered a leaf in the tree-like hierarchy of an MIB. Note: the Internet Engineering Task Force, or IETF, provides standard MIBs you can download at their website. You can download Juniper Networks Enterprise MIBs at the displayed URL. The Junos OS provides support for SNMP versions 1, 2C, and 3. Version 1 is the initial implementation of SNMP that defines the architecture and framework for SNMP. Version 2 added support for community strings, which act as passwords determining access to SNMP agent MIBs. SNMP version 3 is the most up-to-date version and provides enhanced security features, including the definition of a user-based security model, or USM, and a view-based access control model, or VACM. SNMP version 3 provides message integrity, authentication, and encryption, and is a superior security model over SNMP version 2C, which uses plain text community strings. The Junos OS also provides support for remote monitoring, or RMON, events, alarms, and history. Consider the displayed sample SNMP configuration using some common SNMP configuration options. Note: when configuring contact information, you must be as specific as possible. This information is useful when trying to resolve issues with a network device. The example restricts SNMP access to the 10.210.14.0/24 network with read-only authorization. The example also shows the configuration of an SNMP trap group, necessary for the delivery of SNMP traps to an NMS. An NMS, or host, provides the interface for most SNMP monitoring. To monitor SNMP operation directly from a device running the Junos OS, you can use trace options, system logging, and various show SNMP commands. When a trap condition occurs, some traps are logged if the system logging is configured with the appropriate facility and severity levels, regardless of whether a trap group is configured. The sample show command output displayed illustrates that you can also issue standard SNMP manager commands to view agent OID values. MIB, walks, and gets are available from the CLI. You can specify the OIDs in ASCII text format or dotted decimal notation.
Welcome to the lab section of the module.
This lab demonstrates tasks using both the CLI and the JWeb interfaces. Click this button to view a guided demonstration of the tasks performed in the Junos OS CLI interface. Click this button to view a guided demonstration of the tasks performed in the Junos OS JWeb interface.
Welcome to the Junos OS CLI lab. This lab demonstrates typical secondary configuration tasks performed on devices running Junos OS. At the end of this lab, you will be able to define user accounts and authentication options, set up and verify proper operation of system logging, configure and monitor NTP, enable and monitor the operation of SNMP, configure and monitor the configuration archival feature. Click Continue to begin the lab. This lab consists of 2 parts. Click each part to view its guided demonstration. Part 1. Configuring User Authentication. In this lab part, you configure user accounts and related authentication options. To the management network diagram to determine the management address of the VSRX1 device. You can carry out the exercises in this lab using multiple remote terminal sessions. Open a terminal session to the CLI on the VSRX1 device. Log into the student device with lab as the username and lab123 as the password. Note that both the name and the password are case-sensitive. Enter the configuration mode and load the reset configuration file using the load override ijos/lab3start.config command. After the configuration has been loaded, commit the changes. Navigate to Edit System Login and define a custom login class named Juniper with the displayed permissions. Define 2 new user accounts using the displayed information. View the configuration under the Edit System Login hierarchy level. If you are satisfied with the results, activate the new configuration by issuing the commit command. Without closing the session you have just been using, open a new SSH terminal session to the student device. Log in with Walter as the username and Walter123 as the password. Using the new terminal session, try to enter the configuration mode. Enter a question mark at the prompt to view the permitted operational mode command options for the user Walter. Verify that the user Walter can view the configuration and other operational outputs such as interface information. Restart the routing process using the restart routing command. This command restarts the routing protocol process, or RPD, which can be useful when troubleshooting routing problems. Log out from the Walter user account and initiate a new SSH terminal session to the management interface. Log in with Nancy as the username and Nancy123 as the password. Attempt to restart the RPD using the restart routing command. Attempt to clear interface statistics for the GE0/0/0 interface using the clear interfaces statistics GE0/0/0 command. Log out from the Nancy user account and close the terminal session by issuing the exit command. Return to the original CLI terminal session opened by the lab user. Attempt to add the clear permission to the default read-only login class. Issue the show command to view the system login hierarchy. Navigate to the top of the configuration hierarchy and configure a Radius server for use with user authentication. If you refer to the management network diagram, you see the management address for the Radius server. The Radius secret should be Juniper. Configure the authentication order so that user login attempts use only the local password authentication if the Radius server is unreachable. Issue the commit command to activate the changes. From the student desktop, open a new terminal window and start an SSH CLI session. Test the Radius server by trying to log back in with Nancy as the username. In the previous lab step, the defined Radius server was reachable. Because you did not define the username on the Radius server rejected the authentication. Therefore, the software did not consult the local password database. Return to the original CLI session open to the lab user. Change the IP address of the Radius server to 10.1.1.1. You can use the rename command for this change. Do not forget to issue the commit command to activate the change. From the student desktop, open a terminal window and start an SSH CLI session. And try to log in with Nancy as the username using the SSH Nancy at 172.25.11.1 command. 18. Return to the original CLI session open to the lab user. Delete the authentication order statement. When complete, commit the configuration. Part 2. Performing System Management Options. In this lab part, you perform configuration of some common system management features. You also configure and monitor system logging, NTP, SNMP, and configuration archival. Issue the Show System syslog command to view the current system logging configuration. Navigate to the Edit System syslog hierarchy and configure a new system logging file named config changes. Specify a facility of change log and a severity of info. Also, set the severity level for the default messages file to any. Configure the system to send logs to a remote server, running the standard syslog utility. Use the host option. Refer to the management network diagram for the system logging server address. Choose the correct facility that logs access attempts on the system. The current messages log file is already using this facility. Use a severity level of info. Commit the changes when complete. Using the run file list /var/log/ command, verify the creation of a log file named config changes. Configure the system to synchronize its clock with an NTP server. Check the management network diagram for the server's IP address. Use the same server IP address used in the previous step and configure an NTP boot server. Commit the configuration and return to the operational mode when complete. View the config changes log and verify the logging of the latest configuration changes. Manually force synchronization with the NTP server by issuing the setDate NTP operational mode command. Verify synchronization with the NTP server by using the Show NTP Associations command. The system is synchronized with the NTP server if you see the server address in the remote column with an asterisk next to it. Check the current system time using the Show System Uptime command. Return to the configuration mode and configure the system to enable SNMP access using a community value of Junos. The system should enable processing of SNMP messages only when it receives them from the NMS server's IP address. Check the management network diagram for the server's IP address. Configure an SNMP trap group to send traps to the NMS server. The SNMP trap group should send traps whenever an interface transitions to a down state. Name the interface's trap group. Commit the changes using the commit command. To test the SNMP configuration, temporarily disable the GE 0/0/2 interface. Using the set interfaces GE 0/0/2 disable command. Commit the new setting. Next, verify that the interface is down using the Run Show Interfaces GE 0/0/2 terse command. Then, re-enable the interface by issuing the Delete Interfaces GE 0/0/2 disable command. Commit the changes and return to the operational mode when complete. Verify that the interface transition resulted in the generation of a trap by viewing the messages log. Use the pipe symbol and match the GE 0/0/2 interface and the SNMP keyword to parse the messages log output. Next, issue the Show SNMP Statistics command and confirm that the traps value in the output section is not 0. Perform an SNMP MIB walk with the Junos CLI using the Show SNMP MIB walk JNX operating DESCR command. Note that the resolved OID of JNX operating DESCR is case sensitive. The OID is a variable. You are simply using this OID as an example. Enter the configuration mode and configure the system to archive its configuration to a remote FTP server whenever a commit operation occurs. You should configure the archive site as displayed, including the quotation marks. Check the management network diagram for the server's IP address. You should configure FTP as the password. You perform this configuration under the Edit System Archival Configuration hierarchy level. Commit the configuration and return to the operational mode when complete. Verify that the configuration successfully transferred to the remote FTP server by using the Show Log Messages Pipe Match Transfer command. Log out of the assigned device using the exit command. Welcome to the Junos OS JWeb Lab. This lab demonstrates typical secondary configuration tasks performed on devices running Junos OS. You can carry out the tasks performed in this lab using both the CLI and the JWeb interface. At the end of this lab, you will be able to define user accounts and authentication options, set up and verify proper operation of system logging, configure and monitor NTP, enable and monitor the operation of SNMP, configure and monitor the configuration archival feature. Click Continue to begin the lab. This lab consists of 2 parts. Click each part to view its guided demonstration. Part 1. Configuring User Authentication. In this lab part, you configure user accounts and related authentication options. The management network diagram to determine the management address of the VSRX1 device. You carry out the exercises in this lab using both CLI and JWeb interface sessions, at times simultaneously. Open a remote terminal session to the CLI on the assigned VSRX1 device. Log in to the VSRX1 device with lab as the username and lab123 as the password. Note that both the username and password are case-sensitive. Enter the configuration mode and load the reset configuration file using the load override ijos/lab3 start.config command. After the configuration has been loaded, commit the changes. You must define new login classes using the CLI. Navigate to Edit System Login and define a custom login class named Juniper with the displayed permissions. Commit the changes when you complete. Open a web browser on the student desktop. Navigate to https://172.25.11.1. Log in with lab as the username and lab123 as the password, and click Login. Define 2 new user accounts using the displayed information. You can perform this action by completing the following sub-steps. Navigate to Configure, Users, User Management. Click the Add button. Define the Walter account with the displayed information. Click OK when you complete. Repeat sub-steps 1 and 2 to define the Nancy account. Click Save when you complete. View the configuration. If you are satisfied with the results, commit the new configuration. Log out of the lab account. Log in with Walter as the username and Walter123 ! As the password. Navigate to Configure, Device Settings, Basic Settings, System Identity Details. In the DNS server field, attempt to add a DNS server. You can perform this action by completing the following sub-steps. Click the Add button. Enter 8.8.8.8 as the IP address. Confirm the IP address by selecting the checkbox next to the IP address. Then, click Save at the top of the screen. Click Cancel at the top of the screen. Navigate to Administration, Tools, CLI Viewer. Verify that the user, Walter, can view the configuration. Navigate to Monitor, Interfaces, Ports, and verify that the user, Walter, can view port monitoring and other monitoring options. Open a second session to the CLI of the VSRX1 device. Log in using the Walter account and with the password Walter123 ! Restart the routing process using the Restart Routing command. This command restarts the routing protocol process, or RPD, which can be useful when troubleshooting routing problems. Log out from the user Walter and initiate a new terminal session to the management interface for the user Nancy. Use Nancy123 ! As the password. Attempt to restart the routing protocol process using the Restart Routing command. Switch to the JWeb interface for VSRX1. Log out of the Walter account and log in using the Nancy account. Test whether or not you can view the configuration with the Nancy account. You can perform these actions by completing the following substeps. Log out of the Walter account. Log in with Nancy as the username and Nancy123 ! As the password. Navigate to Administration, Tools, CLI Viewer. Return to the original CLI terminal session opened by the lab user. Attempt to add the clear permission to the default read-only login class. Issue the show command to view the system login hierarchy. Navigate to the top of the configuration hierarchy and configure a radius server for use with user authentication. If you refer to the management network diagram, you can see the management address for the radius server. The radius secret should be Juniper. Configure the authentication order so that user login attempts use only local password authentication if the radius server is unreachable. Use commit to activate the changes. From the student desktop, open a new JWeb session. Test the radius server by trying to log back in as Nancy. In the previous lab step, the defined radius server was reachable. Because you did not define the username on the radius server rejected the authentication. Therefore, the software did not consult the local password database. Return to the original CLI session open to the lab user. Change the IP address of the radius server to 10.1.1.1. You can use the rename command for this change. Do not forget to issue the commit command to activate the change. Return to the JWeb interface. Try to log into the system with the Nancy username once again. Log out of the Nancy account. Return to the original CLI session open to the lab user. Delete the authentication order statement. When complete, commit the configuration. Part 2. Performing System Management Options. In this lab part, you perform configuration of some common system management features. You also configure and monitor system logging, NTP, SNMP, and configuration archival. Use the Show System Syslog command to view the current syslog configuration. Navigate to the Edit System Syslog hierarchy and configure a new syslog file named Config Changes. Specify a facility of changelog and a severity of info. Also, set the severity level for the default messages file to any. Commit the changes and exit the configuration mode. Configure the system to send logs to a remote server running the standard syslog utility. You can use the host option. Refer to the management network diagram for the syslog server address. Choose the correct facility that logs access attempts on the system. The current messages log file is already using this facility. Use a severity level of info. Commit the changes when you complete. Return to the Lab User JWeb session and navigate to Administration, Devices, Files. Verify that the file named Config Changes has been created. You can perform this verification by completing the following substeps. In the File Type field, select Log Files. Look for the file named Config Changes. Note down the current size of the file. Navigate to Configure, Device Settings, Basic Settings, Date and Time Details. Configure the system to synchronize its clock with an NTP server. Refer to the management network diagram for the server's IP address and commit the changes when you complete. You can perform these actions by completing the following substeps. In the Time Source field, select the Sync with NTP Server option. Click the Add button to add a new NTP server. Specify the name of the NTP server as 172.25.11.254 and click OK. Click Save at the top. Commit the changes. Navigate to Administration, Devices, Files. View the Config Changes log and verify the logging of the latest configuration changes. You can perform these actions by completing the following substeps. In the File Type field, select Log Files. Check to see if the size of the Config Changes file has changed since you viewed it in Step 4. It should be larger now. To view the content of the file, open a CLI session and use the Show Log Config Changes command. Also, manually force synchronization with the NTP server by issuing the setDateNTP operational mode command. Verify synchronization with the NTP server using the showNTP associations command. The system is synchronized with the NTP server if you see the server address in the remote column with an asterisk next to it. Check the current system time using the showSystemUptime command. Return to the JWeb interface. Navigate to Configure, Device Settings, Basic Settings, SNMP. Configure the system to allow SNMP access using a community value of Junos. The system should allow processing of SNMP messages only when it receives them from the NMS server's IP address. Refer to the management network diagram for the server's IP address. You can perform these actions by completing the following substeps. In the Community field, click the Add button. Specify the community name as Junos, authorization as read-only, and click OK. Configure an SNMP trap group to send traps to the NMS server. The SNMP trap group should send traps whenever an interface transitions to a down state. Name the trap group as Interfaces and commit the changes. You can perform these actions by completing the following substeps. In the Trap Groups field, click the Add button. Name the group as Interfaces and select the link category. In the Targets field, click the Add button and specify the target 172.25.11.254. Confirm the target by selecting the checkbox next to it and click OK at the bottom. Click Save. Commit the changes. To test the SNMP configuration, navigate to Configure, Interfaces, Ports. Temporarily disable the GE 0/0/2 interface and commit the new setting and verify that the interface is down. Next, re-enable the interface and commit the change. You can perform these actions by completing the following substeps. Select the GE 0/0/2.0 interface and click Disable. Confirm the action and commit the change. Verify that the GE 0/0/2.0 interface is down. Re-enable the GE 0/0/2.0 interface. Commit the changes. Switch to the Open Lab Users CLI session of VSRX1. Verify that the interface transition resulted in the sending of a trap by viewing the messages log. Use the pipe symbol and match the GE 0/0/2 interface in the keyword SNMP to parse the messages log output. Next, issue the Show SNMP Statistics command and confirm that the trap's value in the output section is not 0. Perform an SNMP MIB walk with the Junos CLI using the Show SNMP MIB walk JNX operating DESCR command. Note that the Resolved Object Identifier, or OID, of JNX operating DESCR is case-sensitive. The OID is a variable, and the OID used in this step serves as an example. Enter the configuration mode and configure the system to archive its configuration to a remote FTP server whenever a commit operation occurs. You should configure the archive sites as FTP://FTP at 172.25.11.254/archive. Refer to the management network diagram for the server's IP address. You should configure the password as FTP. You perform this configuration under the Edit System Archival Configuration hierarchy level. Commit the configuration and return to the operational mode when you complete. Verify that the configuration is successfully transferred to the remote FTP server using the Show Log Messages Pipe Match Transfer command.
You have reached the end of this module. In this module, you learn to configure user authentication, configure and analyze system logging and tracing, configure and monitor NTP configuration, archive configurations on remote devices, Configure and monitor SNMP.